Right, I've got a compound beam here, and I want to find the reactions at A, C, and E. And really the way I treat this is breaking it into three free body diagrams. So let me draw all the free body diagrams right off the bat. So again, at A, I've got um, a fixed, so I've got AX, AY, and a moment at A. So there's AX, there's AY, and there's a moment about A. I've got 9 kilonewtons at the center, and then I've got pin joint BX and BY, which I'll just assume is right and to the left, meaning when I look at member CD, I've got to flip those directions. So BX is to the left, BY is down. I've got a reaction at C that I'm trying to figure out. I've got a couple moment applied here at 10, and then I've got a dx and dy pin just like I had before, okay, which of course when I flip over to E, I'm going to have E, dx and dy are going to flip, okay, like so. Oops, that's not a B, it should be a D, and then I've got 10 kilonewtons straight down. Now, I'm going to go through this kind of quickly. Hopefully you'll be able to follow things around. And I'm actually going to start over on this one because notice on the right member I've got 3 unknowns. Each one of these has 3 equations. I can actually solve this one. Hopefully you realize that dx does not exist. There's no force in the x direction, so that goes to 0. Summing the forces in that direction has to equal 0. Now, also from symmetry, hopefully you recognize that these are each going to be 5, right? Because 10's at the middle, okay? So these have to both be up equaling 5 like so, which means that this dy is in the wrong direction. It should be downward, and it should be 5, okay? So I've got that. Now, I should also recognize that bx is going to go to 0. So if I sum the forces in the x direction on this guy, there are no forces in the x direction, so you've got that, which means this bx goes to 0. Now, this one's not going to be quite as straightforward, so I'm going to go ahead and write some equations here, right? So if I sum the forces in the y direction, I've got c minus by minus 5 equals 0, okay? I can also sum the moments about c, okay? I'm going to get the negative 10. You don't want to forget that. I'm going to have negative 1.5 times 5, and I'm going to have positive 1.5 times by equal to 0. Okay, from that, I find by equals 11.7. Plugging that in up here, I find that c equals 16, 16.7. Okay, so this c then becomes 16.7. Well, that is a bad decimal point. Let me try that again. 16.7. That's going to be kilonewtons. That's an answer, so I should probably box that guy in there. Okay. Oh, I guess this is E. I should probably box this one in there because we're trying to find that one. Okay. And then BY, I have drawn correctly, and it's 11.7. And then this BY is also 11.7. Okay. So again, now moving to this last one, AY is going to go to, or I'm sorry, AX is going to go to 0. This should be AY. Labeled those incorrectly. AX should go to 0 because BX is 0. Right? Those are the only things. AY equals, I don't know, I have that flipped the wrong way, right? That has to be downward. And that has to be 2.7 kilonewtons, right? Because I've got 9, 2.7 down to equal that 11.7 upward. Okay, and I suppose I'll go ahead and write my moment equation. I'll sum the moments about A. I recognize I've got my moment about A that I'm trying to figure out. I have negative 1.5 times 9, and I have a positive 3 times 11.7 equal to 0. So my reaction at A then has to be negative. So I have it drawn backwards, okay, which is fine. But 21.5, and that'll be kilonewton meters. Again, I get a negative on that, so it's flipped the other direction. But those are those reaction forces that I've got. Again, with a compound beam like this, you just treat it like a frame. You break it up into pieces and take each piece at a time, finding the reactions as appropriate.